Hello class, this is lesson 10-3 in your textbook, and it's titled How to Apply Properties of Chords. So we talked about chords earlier. It is a line segment that reaches all the way across a circle. It can go through the center or it doesn't have to. And so all that we're going to introduce are some theorems related to chords. Theorem 10.3 says, in the same circle, or it could be in congruent circles, two minor arcs are congruent if and only if their corresponding chords are congruent. So that means that if I found that AB and CD, that those two arcs are congruent, so AB and CD are congruent, if and only if the segments, those chord segments, are congruent as well. So if, I'm going to put the abbreviation for if and only if, AB is congruent to CD. Alright, so that is our first theorem for today. We have 4 of them. The second one says, Theorem 10.4. If one chord is a perpendicular bisector, which means that the chord is bisecting the segment and it's also meeting at 90 degrees. So if it's a perpendicular bisector of another chord, then the first chord is the diameter. So that's the only case to have two chords that are meeting at 90 degrees, is that one of them has to be going through the diameter. Awesome. Theorem 10.5 says, if a diameter of a circle is perpendicular to a chord, then the diameter bisects the chord and its arc. So not only is the chord being bisected, but also the arc, all the way from F around to D, is being bisected, which means that FG is congruent to GD. And the last theorem for today is Theorem 10.6. And it says, in the same circle, or in congruent circles, two chords are congruent if and only if they are equidistant from the center. So another way to prove that AB and CD are congruent is if the distance from the center is exactly the same. And we know that we find the distance by finding the line that's perpendicular to that chord. And that's all that we're going to talk about, is introducing these 4 theorems, and then we're going to do a lot of practice when we get to class. Thank you.